Hello everyone, my name is E. Sai Kumar and I am from ECE D section. My topic is underwater radio communication. Let us see the introduction. Wireless communication technology today has become part of our daily life. It is difficult due to factors such as multipath propagation, time variations of the channel, small available bandwidth, and strong signal attenuation, especially over long distance. Underwater communications uses acoustic waves instead of electromagnetic waves. History of underwater radio communications. The science of underwater acoustic began in 1490 when Leonardo da Vinci stated in 1687 Isaac Newton wrote his mathematical principles of natural philosophy, which included the first mathematical treatment of sound in water. Communication channel. The signals that are used to carry digital information through an underwater channel are acoustic signals. An underwater acoustic signal or channel presents a communication system designer with many difficulties. The signal is subject to multipath propagation, which is particularly pronounced on horizontal channels. The deficiency in current communication. Radio waves propagated underwater at extremely low frequencies, which is 30 Hz to 300 Hz, and require large antenna and high transmission power. Optical waves do not suffer much attenuation but are affected by scattering. Acoustic waves are the single best solution for communicating underwater. Underwater wireless communication technology. Radio waves do not propagate well underwater due to high energy absorption of water. Therefore, underwater communication are based on acoustic links characterized by large propagation delays. Acoustic channels have low bandwidth. The propagation speed of acoustic signals in water is typically 1500 milliseconds meters per second. It cannot rely on the global positioning system GPS. Underwater networks. Integrated networks of instruments, sensors, robots, and vehicles which operate together in variety of underwater environments. Depending on the application, there are two types of acoustic networks. Centralized network node communicate through a base station that covers one cell. Here is the representation of centralized neutral topology. In a decentralized network, nodes communicate via peer-to-peer. To accommodate multiple users within a selected network topology, the communication channel must be shared. Methods for channel sharing are based on scheduling or on contention. Modem model. The model the modem has successfully been developed in a number of trials. This modem is implemented in a fixed point DSP with a floating point coprocessor. Multi-user communications each at 1.4 kb per second in 5 kHz band. Autonomous Water Vehicle AUV is a robot that travels underwater. Modems fit easily into the AUV. It has low power consumption and it is very reliable for high level throughput. Now let us see the factors influencing acoustic communication. First one is the path loss. Due to attenuation and geometric spreading, there will be the path loss. And second one is noise. Man-made noise and ambient noise due to hydrodynamics. And next is multipath propagation and high propagation delay. And the advantages of underwater radio communication is it can be used to provide early warnings of tsunamis generated by undersea earthquakes. It provides privacy leakage. It avoids privacy leakage. Pollution monitoring. And the disadvantages of underwater radio communications are the battery power is limited and usually batteries cannot be recharged easily. The available bandwidth is severely limited. High bit error rate. multipath problems, and the applications are marine archaeology, search missions, defense, and etc. And the conclusion of my topic is the aim of this is to build a acoustic communication as in figure. This topic gives the overall view of the necessity of underwater wireless communication and its applications. My reference, thank you.